An automobile, autocar, motorcar or car is a wheeled motor vehicle used for transporting passengers, which also carries its own engine or motor. Most definitions of the term specify that automobiles are designed to run primarily on roads, to have seating for 1 to 8 people, to typically have 4 wheels, and to be constructed principally for the transport of people rather than goods. The year 1886 is regarded the year of birth of the modern automobile with the Benz Patent-Motorwagen, by German inventor Karl Benz. Motorized wagons soon replaced animal-drafted carriages, especially after automobiles became affordable for many people when the Ford Model T was introduced in 1908. The term motor car has formerly also been used in the context of electrified rail systems to denote a car which functions as a small locomotive but also provides space for passengers and baggage. These locomotive cars were often used on suburban routes by both interurban and intercity railroad systems. It was estimated in 2010 that the number of automobiles had risen to over 1 billion vehicles, up from the 500 million of 1986. The numbers are increasing rapidly, especially in China, India and other NICs. Etymology: the word automobile comes, via the French automobile, from the ancient Greek word I plus or minus a 1/2 iiy and the Latin mobilis, meaning a vehicle that moves itself. The loan word was first adopted in English by the New York Times in 1899. The alternative name car is believed to originate from the Latin word carus or carum, or the Middle English word car. In turn these are said to have originated from the Gaulish word carros. History: the first working steam-powered vehicle was designated a Euro, and most likely built a Euro by Ferdinand Verbiest, a Flemish member of a Jesuit mission in China around 1672. It was a 65 cm long-scale model toy for the Chinese emperor, that was unable to carry a driver or a passenger. It is not known if Verbiest's model was ever built. Nicholas Joseph Cognate is widely credited with building the first full-scale, self-propelled mechanical vehicle or automobile in about 1769. He created a steam-powered tricycle. He also constructed 2 steam tractors for the French army, one of which is preserved in the French National Conservatory of Arts and Crafts. His inventions were however handicapped by problems with water supply and maintaining steam pressure. In 1801, Richard Trevithick built and demonstrated his Puffing Devil road locomotive, believed by many to be the first demonstration of a steam-powered road vehicle. It was unable to maintain sufficient steam pressure for long periods, and was of little practical use. The development of external combustion engines is detailed as part of the history of the automobile, but often treated separately from the development of true automobiles. A variety of steam-powered road vehicles were used during the first part of the 19th century, including steam cars, steam buses, phaetons, and steam rollers. Sentiment against them led to the Locomotive Acts of 1865. In 1807 Nika copyright for near copyright PCE and his brother Claude probably created the world's first internal combustion engine which they called a Pyrrha copyright Ola 4, but they chose to install it in a boat on the River Seine in France. Coincidentally, in 1807 the Swiss inventor for a Section Y Isaac de Rivaz designed his own de Rivaz internal combustion engine and used it to develop the world's first vehicle to be powered by such an engine. The near copyright PCE's Pyrrha copyright Ola 4 was fueled by a mixture of lycopodium powder, finely crushed coal dust and resin that were mixed with oil, whereas de Rivaz used a mixture of hydrogen and oxygen. Neither design was very successful, as was the case with others, such as Samuel Brown, Samuel Morey, and Etienne Lenoir with his Hippomobile, who each produced vehicles powered by internal combustion engines. In November 1881, French inventor Gustave Trover copyright demonstrated a working 3-wheeled automobile powered by electricity at the International Exposition of Electricity, Paris. Although several other German engineers were working on the problem at about the same time, Karl Benz generally is acknowledged as the inventor of the modern automobile. In 1879, Benz was granted a patent for his first engine, which had been designed in 1878. Many of his other inventions made the use of the internal combustion engine feasible for powering a vehicle. His first motor wagon was built in 1885 in Mannheim, Germany. He was awarded the patent for its invention as of his application on January 29, 1886. Benz began promotion of the vehicle on July 3, 1886, and about 25 Benz vehicles were sold between 1888 and 1893, when his first four-wheeler was introduced along with a model intended for affordability. They also were powered with four-stroke engines of his own design. Émile Roger of France, already producing Benz engines under license, now added the Benz automobile to his line of products. Because France was more open to the early automobiles, initially more were built and sold in France through Roger than Benz sold in Germany. In August 1888, Bertha Benz, the wife of Karl Benz, undertook the first road trip by car, to prove the roadworthiness of her husband's invention. In 1896, Benz designed and patented the first internal combustion flat engine, called box motor. During the last years of the 19th century, Benz was the largest automobile company in the world with 572 units produced in 1899 and, because of its size, Benz and C. became a joint stock company. The first motor car in Central Europe and one of the first factory-made cars in the world, was produced by Czech company Nesselstdorfer Wagenbau in 1897, the Prague currency silent automobile. Daimler and Maybach founded Daimler Motorengesellschaft in Cannstatt in 1890, and sold their first automobile in 1892 under the brand name, Daimler. It was a horse-drawn stagecoach built by another manufacturer, that they retrofitted with an engine of their design. By 1895 about 30 vehicles had been built by Daimler and Maybach either at the Daimler Works or in the Hotel Hermann, where they set up shop after disputes with their backers. Benz, Maybach and the Daimler team seem to have been unaware of each other's early work. They never worked together. By the time of the merger of the two companies, Daimler and Maybach were no longer part of DMG. Daimler died in 1900 and later that year, Maybach designed an engine named Daimler Mercedes, that was placed in a specially ordered model built to specifications set by Emil Jelinek. This was a production of a small number of vehicles for Jelinek to race and markets in his country. 2 years later, in 1902, a new model DMG automobile was produced and the model was named Mercedes after the Maybach engine which generated 35 HP. Maybach quit DMG shortly thereafter and opened a business of his own. Rights to the Daimler brand name were sold to other manufacturers. Karl Benz proposed cooperation between DMG and Benz and C. When economic conditions began to deteriorate in Germany following the First World War, but the directors of DMG refused to consider it initially. Negotiations between the two companies resumed several years later when these conditions worsened and, in 1924 they signed an agreement of mutual interest, valid until the year 2000. Both enterprises standardized design, production, purchasing, and sales and they advertised or marketed their automobile models jointly, although keeping their respective brands. On June 28, 1926, Benz and C and DMG finally merged as the Daimler-Benz Company, baptizing all of its automobiles Mercedes-Benz, as a brand honoring the most important model of the DMG automobiles, the Maybach design later referred to as the 1902 Mercedes 35 HP, along with the Benz name. Karl Benz remained a member of the board of directors of Daimler-Benz until his death in 1929, and at times, his two sons participated in the management of the company as well. In 1890, a Permil Levasseur and Armand Peugeot of France began producing vehicles with Daimler engines, and so laid the foundation of the automobile industry in France. The first design for an American automobile with a gasoline internal combustion engine was made in 1877 by George Selden of Rochester, New York. Selden applied for a patent for an automobile in 1879, but the patent application expired because the vehicle was never built. After a delay of 16 years and a series of attachments to his application, on November 5, 1895, Selden was granted a United States patent for a two-stroke automobile engine, which hindered, more than encouraged, development of automobiles in the United States. His patent was challenged by Henry Ford and others, and overturned in 1911. In 1893, the first running, gasoline-powered American car was built and road-tested by the Deraille brothers of Springfield, Massachusetts. The first public run of the Deraille motor wagon took place on September 21, 1893, on Taylor Street in Metro Center, Springfield. The Studebaker Automobile Company, subsidiary of a long-established wagon and coach manufacturer, started to build cars in 1897 and commenced sales of electric vehicles in 1902 and gasoline vehicles in 1904. In Britain, there had been several attempts to build steam cars with varying degrees of success, with Thomas Rickett even attempting a production run in 1860. Sandler from Malvern is recognised by the Veteran Car Club of Great Britain as having made the first petrol-powered car in the country in 1894, followed by Frederick William Lanchester in 1895, but these were both one-offs. The first production vehicles in Great Britain came from the Daimler Company, a company founded by Harry J. Lawson in 1896, after purchasing the right to use the name of the engines. Lawson's company made its first automobiles in 1897, and they bore the name Daimler. In 1892, German engineer Rudolf Diesel was granted a patent for a new rational combustion engine. In 1897, he built the first diesel engine. Steam, electric, and gasoline-powered vehicles competed for decades, with gasoline internal combustion engines achieving dominance in the 1910s. Although various pistonless rotary engine designs have attempted to compete with the conventional piston and crankshaft design, only Mazda's version of the Wankel engine has had more than very limited success. Mass production. The large-scale, production line manufacturing of affordable automobiles was debuted by Ransom Olds in 1902 at his Oldsmobile factory located in Lansing, Michigan, and based upon the assembly line techniques pioneered by Marcus Ambard Brunel at the Portsmouth Block Mills, England in 1802. The assembly line style of mass production and interchangeable parts had been pioneered in the U.S. by Thomas Blanchard in 1821, at the Springfield Armory in Springfield, Massachusetts. This concept was greatly expanded by Henry Ford, beginning in 1914. As a result, Ford's cars came off the line in 15-minute intervals, much faster than previous methods, increasing productivity eightfold, while using less manpower. It was so successful, paint became a bottleneck. Only Japan Black would dry fast enough, forcing the company to drop the variety of colors available before 1914, until fast-drying Duco lacquer was developed in 1926. This is the source of Ford's apocryphal remark, "Any color as long as it's black." In 1914, an assembly line worker could buy a Model T with 4 months' pay. Ford's complex safety procedure is especially assigning each worker to a specific location instead of allowing them to roam about dramatically reduced the rate of injury. The combination of high wages and high efficiency is called Fordism, and was copied by most major industries. The efficiency gains from the assembly line also coincided with the economic rise of the United States. The assembly line forced workers to work at a certain pace with very repetitive motions, which led to more output per worker, while other countries were using less productive methods. In the automotive industry, its success was dominating, and quickly spread worldwide, seeing the founding of Ford France and Ford Britain in 1911, Ford Denmark 1923, Ford Germany 1925. In 1921, Citroën was the first native European manufacturer to adopt the production method. Soon, companies had to have assembly lines, or risk going broke. By 1930, 250 companies which did not, had disappeared. Development of automotive technology was rapid, due in part to the hundreds of small manufacturers competing to gain the world's attention. Key developments included electric ignition and the electric self-starter, independent suspension, and four-wheel brakes. Since the 1920s, nearly all cars have been mass-produced to meet market needs, so marketing plans often have heavily influenced automobile design. It was Alfred P. Sloan who established the idea of different makes of cars produced by one company, so buyers could move up as their fortunes improved. Reflecting the rapid pace of change, makes shared parts with one another, so larger production volume resulted in lower costs for each price range. For example, In the 1930s, La Sol's, sold by Cadillac, used cheaper mechanical parts made by Oldsmobile. In the 1950s, Chevrolet shared hood, doors, roof, and windows with Pontiac. By the 1990s, corporate powertrains and shared platforms were common. Even so, only major makers could afford high costs, and even companies with decades of production, such as Apperson, Cole, Doris, Haynes, or Premier, could not manage. Of some 200 American car makers in existence in 1920, only 43 survived in 1930, and with the Great Depression, by 1940, only 17 of those were left. In Europe much the same would happen. Morris set up its production line at Cowley in 1924, and soon outsold Ford, while beginning in 1923 to follow Ford's practice of vertical integration, buying Hotchkiss, Wrigley, and Osberton, for instance, as well as competitors, such as Wolseley. In 1925, Morris had 41% of total British car production. Most British small car assemblers, from Abbey to Xtra, had gone under. Citroën did the same in France, coming to cars in 1919. Between them and other cheap cars in reply such as Renault's 10CV and Peugeot's 5CV, they produced 550,000 cars in 1925, and Mors, Hertu, and others could not compete. Germany's first mass-manufactured car, the Opel 4 Picoseconds Lobfrosch, came off the line at Rüsselsheim in 1924, soon making Opel the top car builder in Germany, with 37.5% of the market. User interface. Cars are equipped with controls used for driving, parking, and passenger comfort and safety. Modern cars' controls are now standardized, but this was not always the case. Controls are evolving in response to new technologies, for example the electric car. Since the car was first invented, its controls have become fewer and simpler through automation. For example, all cars once had a manual controls for the choke valve, clutch, ignition timing, and a crank instead of an electric starter. However, new controls have also been added to vehicles, making them more complex. Examples include air conditioning, navigation systems, and in-car entertainment. Another trend is the replacement of physical knob and switches for secondary controls with touch-screen controls such as BMW's iDrive and Ford's My Ford Touch. Weight. The weight of a car influences fuel consumption and performance, with more weight resulting in increased fuel consumption and decreased performance. According to a research conducted by Julian Allwood of the University of Cambridge, global energy use could be heavily reduced by using lighter cars, and an average weight of 500 kg has been said to be well achievable. In some competitions such as the Shaleco Marathon, average car weights of 45 kg have also been achieved. These cars are only single-seaters, but it nevertheless demonstrates the huge degree in which car weights can still be reduced, and the subsequent lower fuel use. Seating and body style. Most cars are designed to carry multiple occupants, often with 4 or 5 seats. Larger cars can often carry 6, 7 or more occupants depending on the internal range of seats. Sports cars are often designed with only 2 seats, and very occasionally 3 seats. The differing needs for passenger capacity and their luggage has resulted in a large variety of body styles to suit personal requirements such as the sedan saloon, hatchback, station wagon estate and multi-purpose vehicle minivan. Fuel and propulsion technologies. Most automobiles in use today are propelled by an internal combustion engine, fueled by deflagration of gasoline or diesel. Both fuels are known to cause air pollution and are also blamed for contributing to climate change and global warming. Rapidly increasing oil prices, concerns about oil dependence, tightening environmental laws and restrictions on greenhouse gas emissions are propelling work on alternative power systems for automobiles. Efforts to improve or replace existing technologies include the development of hybrid vehicles, plug-in electric vehicles and hydrogen vehicles. Vehicles using alternative fuels such as ethanol flexible fuel vehicles and natural gas vehicles are also gaining popularity in some countries. Oil consumption in the 20th and 21st centuries has been abundantly pushed by automobile growth. The 1985 Euro 2003 oil glut even fueled the sales of low-economy vehicles in OECD countries. The BRIC countries might also kick in, as China briefly was the first automobile markets in December 2009. Safety. Road traffic injuries represent the leading cause in worldwide injury-related deaths. Mary Ward became one of the first documented automobile fatalities in 1869 in Parsonstown, Ireland, and Henry Bliss one of the United States' first pedestrian automobile casualties in 1899 in New York City. There are now standard tests for safety in new automobiles, like the Euro NCAP and the US NCAP tests, and insurance industry-backed tests by the Insurance Institute for Highway Safety. Worldwide, road traffic is becoming ever safer, in part due to efforts by the government to implement safety features in cars, and by implementing safety components such as speed bumps on the roads themselves. Costs and benefits. The costs of automobile usage, which may include the cost of acquiring the vehicle, repairs and auto maintenance, fuel, depreciation, driving time, parking fees, taxes, and insurance, are weighed against the cost of the alternatives, and the value of the benefits euro perceived and real euro of vehicle usage. The benefits may include on-demand transportation, mobility, independence and convenience. Similarly, the costs to society of encompassing automobile use, which may include those of maintaining roads, land use, pollution, public health, healthcare, and of disposing of the vehicle at the end of its life, can be balanced against the value of the benefits to society that automobile use generates. The societal benefits may include economy benefits, such as job and wealth creation, of automobile production and maintenance, transportation provision, society well-being derived from leisure and travel opportunities, and revenue generation from the tax opportunities. The ability for humans to move flexibly from place to place has far-reaching implications for the nature of societies. Environmental impact. While there are different types of fuel that may power cars, most rely on gasoline or diesel. The United States Environmental Protection Agency states that the average vehicle emits 8,887 grams of carbon dioxide per gallon of gasoline. The average vehicle running on diesel fuel will emit 10,180 grams of carbon dioxide. Many governments are using fiscal policies to influence vehicle purchase decisions, with a low CO2 figure often resulting in reduced taxation. Fuel taxes may act as an incentive for the production of more efficient, hence less polluting, car designs and the development of alternative fuels. High fuel taxes may provide a strong incentive for consumers to purchase lighter, smaller, more fuel-efficient cars, or to not drive. On average, today's automobiles are about 75% recyclable, and using recycled steel helps reduce energy use and pollution. In the United States Congress, federally mandated fuel efficiency standards have been debated regularly. Passenger car standards have not risen above the 27.5 miles per U.S. gallon standard set in 1985. Light truck standards have changed more frequently, and were set at 22.2 miles per U.S. gallon in 2007. The manufacture of vehicles is resource-intensive, and many manufacturers now report on the environmental performance of their factories, including energy usage, waste and water consumption. The growth in popularity of the car allowed cities to sprawl, therefore encouraging more travel by car, resulting in inactivity and obesity, which in turn can lead to increased risk of a variety of diseases. Transportation is a major contributor to air pollution in most industrialized nations. According to the American Surface Transportation Policy Project, nearly half of all Americans are breathing unhealthy air. Their study showed air quality in dozens of metropolitan areas has worsened over the last decade. Animals and plants are often negatively impacted by automobiles via habitat destruction and pollution. Over the lifetime of the average automobile, the loss of habitat potential may be over 50,000 square meters based on primary production correlations. Animals are also killed every year on roads by automobiles, referred to as roadkill. More recent road developments are including significant environmental mitigations in their design, such as green bridges to allow wildlife crossings, and creating wildlife corridors. Growth in the popularity of vehicles and commuting has led to traffic congestion. Brussels was considered Europe's most congested city in 2011 according to TomTom. Future car technologies. Automobile propulsion technology under development include gasoline electric and plug-in hybrids, battery electric vehicles, hydrogen cars, biofuels, and various alternative fuels. Research into future alternative forms of power include the development of fuel cells, homogeneous charge compression ignition, Stirling engines, and even using the stored energy of compressed air or liquid nitrogen. New materials which may replace steel car bodies include duraluminum, fiberglass, carbon fiber, and carbon nanotubes. Telematics technology is allowing more and more people to share cars, on a pay-as-you-go basis, through car share and carpool schemes. Communication is also evolving due to connected car systems. Autonomous car. Fully autonomous vehicles, also known as driverless cars, already exist in prototype, and are expected to be commercially available around 2020. According to urban designer and futurist Michael E. Arth, driverless electric vehicles in conjunction with the increased use of virtual reality for work, travel, and pleasure could reduce the world's 800 million vehicles to a fraction of that number within a few decades. This would be possible if almost all private cars requiring drivers, which are not in use and parked 90% of the time, would be traded for public self-driving taxis that would be in near constant use. This would also allow for getting the appropriate vehicle for the particular need. A bus could come for a group of people, a limousine could come for a special night out, and a Segway could come for a short trip down the street for one person. Children could be chauffeured in supervised safety, DUIs would no longer exist, and 41,000 lives could be saved each year in the US alone. Open source development. There have been several projects aiming to develop a car on the principles of open design. The projects include Oscar, Riversimple and C.M.N. None of the projects have reached significant success in terms of developing a car as a whole both from hardware and software perspective, and no mass production-ready open source-based design have been introduced as of late 2009. Some car hacking through onboard diagnostics has been done so far. Industry. The automotive industry designs, develops, manufactures, markets, and sells the world's motor vehicles. In 2008, more than 70 million motor vehicles, including cars and commercial vehicles, were produced worldwide. In 2007, a total of 71.9 million new automobiles were sold worldwide, 22.9 million in Europe, 21.4 million in the Asia-Pacific region, 19.4 million in the USA and Canada, 4.4 million in Latin America, 2.4 million in the Middle East and 1.4 million in Africa. The markets in North America and Japan were stagnant, while those in South America and other parts of Asia grew strongly. Of the major markets, China, Russia, Brazil and India saw the most rapid growth. About 250 million vehicles are in use in the United States. Around the world, there were about 806 million cars and light trucks on the road in 2007. They burn over 260 billion US gallons of gasoline and diesel fuel yearly. The numbers are increasing rapidly, especially in China and India. In the opinion of some, urban transport systems based around the car have proved unsustainable, consuming excessive energy, affecting the health of populations, and delivering a declining level of service despite increasing investments. Many of these negative impacts fall disproportionately on those social groups who are also least likely to own and drive cars. The sustainable transport movement focuses on solutions to these problems. In 2008, with rapidly rising oil prices, industries such as the automotive industry are experiencing a combination of pricing pressures from raw material costs and changes in consumer buying habits. The industry is also facing increasing external competition from the public transport sector, as consumers re-evaluate their private vehicle usage. Roughly half of the U.S.'s 51 light vehicle plants are projected to permanently close in the coming years, with the loss of another 200,000 jobs in the sector, on top of the 560,000 jobs lost this decade. combined with robust growth in China. In 2009, this resulted in China becoming the largest automobile producer and market in the world. China 2009 sales had increased to 13.6 million, a significant increase from 1 million of domestic car sales in 2000. Alternatives to the automobile. Established alternatives for some aspects of automobile use include public transit such as buses, trolleybuses, trains, subways, tramways, light rail, cycling, and walking. Car share arrangements and carpooling are also increasingly popular. The U.S. market leader in car sharing has experienced double-digit growth in revenue and membership growth between 2006 and 2007, offering a service that enables urban residents to share a vehicle rather than own a car in already congested neighborhoods. Bike share systems have been tried in some European cities, including Copenhagen and Amsterdam. Similar programs have been experimented with in a number of U.S. cities. Additional individual modes of transport, such as personal rapid transit, could serve as an alternative to automobiles if they prove to be socially accepted. See also. References. Further reading: Halberstam, David, The Reckoning, New York, Morrow, 1986. ISBN 0-688-04838-2, K. Jane Hulls, Asphalt Nashna: How the Automobile Took Over America, and How We Can Take It Back, New York, Crown, 1997. ISBN 0-517-58702-5, Heathcote Williams, Autogeddon, New York, Arcade, 1991. ISBN 1-55970-176-5, Wolfgang Sachs, For Love of the Automobile, Looking Back into the History of Our Desires, Berkeley, University of California Press, 1992, ISBN 0-520-06878-5, external links, FAR Copyright DAO Copyright Ration Internationale de l'Automobile, Forum for the Automobile and Society.